Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10 including the back ones. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. So for shop A, they're selling the rulers in lots of 3. And so we just need to get our 60 and divide it by 3 to figure out how many lots of 3 we have. So we've got 20. So if one bundle of rulers costs £1.50, then 20 times £1.50 would be £30. So in total it would cost £30 at shop A. We're going to do the same for shop B. Their bundles are 5 rulers, so we're going to do 60 divided by 5, which is 12. So we're going to buy 12 bundles at £2 each, and that will be £24. So the cheapest price is at shop B at £24. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. To answer this question, we're going to find the answers to the numerator and denominator, then we're going to divide the two. So 3 plus 42 is 45. 5 times 3 is 15. And what this line means in the fraction, it means divide. So we're going to do 45 divided by 15. So I'm just going to go through the 15 times table and just work out that's 1 times 15, 2 times 15, 3 times 15. So 3 15s in 45. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. So I'm going to start just by copying this question. When we're told to solve, it means we need to find out what x is. And there's a nice little strategy to be able to do that. And the first thing we do is just draw lines left and right of the equal sign. And we look at the left hand side and work out what is stopping x from being on its own. Well, this minus 10 here is stopping x from being on its own. So we need to get rid of that somehow. And we do that by doing the opposite of it. So what is the opposite of take away 10? Well, that's going to be plus 10. But you can't just do that to the left-hand side. You have to do the same thing to the right-hand side. So on the left-hand side now, we're left with just x because we've got rid of that take away 10. And on the right-hand side, we do 6 plus 10, which is 16. So our solution is x equals 16. So the word integer just means whole number. So we're looking for all the whole numbers that x can be. Well, it says here that x is between -2 and 3. So we can first of all fill out that -1, 0, 1, and 2 are definitely values that x can be. The next thing we look at is, can it be -2? Well, there's no little equal sign underneath the inequality, so it can't be equal to -2. But there is one for the 3, so it can actually equal 3. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So 3 as a percentage of 10, the first thing we can do is write that as a fraction, so 3 over 10. And then I can get the bottom to be 100 and the top will become the percentage. So I can times top number here by 10, so that becomes 30 over 100. And percent means per 100. Here we've got 30 per 100, or 30%. So the answer is 30%. So to do this question, you just need a piece of paper, a ruler, and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on, will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot, like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here, and I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side, and I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first two sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the two lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. So we need to rewrite this fact here so that it looks like this. So I'm just going to focus on this fact, and what I'm going to do is divide 99 both sides. So we end up with 24 equals 2,376 divided by 99. Now you can see that that looks like that, which is kind of the point. So I'm just going to swap that around. So 2,376 divided by 99 equals 24. And I'm going to write this underneath so we can see the similarity. So 2,376,000 divided by 99,000 equals. Okay, let's have a look at what's happening between these two numbers. So this part here is multiplied by 1,000, and this part here is multiplied by 100. So what effect is the fact that the first numbers multiplied by 1,000 going to have on our answer? Well, it's obviously going to make it 1,000 times bigger. So it will make it 24,000, won't it? 2, 3. So that's that bit done. But what effect will multiplying the denominator have by 100 on our answer? Okay, so if you think about a half, if we times the bottom by 100, it becomes 1 over 200. Now, what is this compared to that? What is 1 over 200 compared to 1/2? Well, it's 100 times smaller. So when you're doing stuff to the denominator, you're actually making it smaller. So this times 100 is making our answer 100 times smaller. So we just knock off 2 of the zeros. We divide it by 100. So our answer will be 240. I'm going to start by writing out all the outcomes. So I'm going to start with trout. So for trout, as a main, I could have had biscuits for dessert. Trout as a main, I could have had cheesecake for dessert. Trout as a main, I could have pancakes as a dessert. Then I'm going to move on to a curry for main. So for curry for main, I could have had biscuits, could have had cheesecake, and I could have had pancakes. Now, to work out the probability, it's the amount of successful outcomes over the total amount of outcomes. So successful for this is a curry and pancakes. So curry and pancakes is a successful outcome, so it's just 1. The total amount are 1, 2, 3, 4, 5, 6. So the chance of me picking at random a curry and pancakes is 1 over 6. So 100% of 120 is 120. And let's put that in a bubble. So we're going to split that bubble up to find out what 10% is. And to find 10%, all we need to do is divide it by 10. So divide 120 by 10, you get 12. And then we want to split that bubble up again into 5%. And 5% is found just by halving it again. And so that would be, or just halving it, so that would be half of 12, which is 6. We could do with 1% as well. And we're trying to get to 26%, so we'll do 1%. So dividing the 10% by 10 again, 1.2. And we could do with 20%, and 20% just means we're going to double the 10%. So double 12 will be 24. So to work out 26%, we need to add these together to get to 26. So we're going to add these numbers here together. Okay, so we've got a 6, a 1.2, and a 24. And we're adding them together. And that would be 11, so carry the 1, and that would be 3. Now, it says to decrease it by 26%. So 26% is 31.2. So we need to subtract that. So we're going to do 120, take away 31.2. So I need to borrow 1 from the 2 to make that a 10, borrow 1 there to make that a 10, and that would be a 9. So 10 take away 2 is 8. 9 take away 1 is 8. And there's a 1 here, so we need to borrow that 1. That's 11 take away 3, which is 8. So our answer is 88.8. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the center, that's a diameter. If you've got a line just going to the center, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. The easiest way to compare fractions, decimals, and percentages is to convert them all into decimals. So I'm just going to convert this percentage to a decimal, and to do that, you just divide by 100. And I'm going to convert this fraction by timesing top and bottom by 10. And we know that 4/10 is 0.4. Then I'm just going to put all of these numbers in a place value grid, place value table. And we've got units, we've got tenths, we've got hundredths. Shouldn't need any more than that. So we've got 0.4, 0.43, and 0.27. Now what we do is we start on the left hand side and we find the smallest, because we're looking for it in ascending order. And the smallest tenth is the 2 there, so it's 0.27. So this is our smallest number, 0.27. Now the next two are equal, so we look at the hundredths, and this technically has a 0 there, so 0 is the next smallest. Now 0.40 was 2/5, so make sure you have the original fraction in and not 0.4. And then the largest one is the 0.43, which was 43%. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. So adjacent angles in a parallelogram add up to 180, and the reason for that is that we've got a set of parallel lines here, and both of these angles are within that set of parallel sides, so they're actually co-interior, interior, or allied angles, whichever you choose to call them, and so we know that they're going to add up to 180. So we're going to do 180, take away the 61 we already have there, which is 119. So our answer is 119 degrees. It's quite difficult to see where to start with this question, but I do notice that we've got the f terms here, 44f, and an f term here, 16f. So there must be some way of linking the two, and actually there is. If you look, we've got, let's just use a different colour, we've got C angles here, or interior angle. We've got the two parallel lines on the left and the right hand side, and a line going connecting the two, and it kind of makes the C that you can see in purple. So that means that we know that angle CAB plus angle ABD are going to equal 180. So if we add them together, 16f plus 44f is going to equal 180 degrees. The reason for that is that they are interior. Now you could call that co-interior or allied angles or interior. All three of those will get the mark for the working out. So we're going to just put our tramlines in and solve this to find out what f is. So 16f plus 44f is going to be 60f, and 180, so we're going to divide by 60 both sides, and we get f equal to 3. Right, the other thing I notice is that we have a parallelogram, and something we know about a parallelogram is that the opposite angles are equal. Now you could also look at this angle and this angle also adding up to 180, they're also interior angles. Kind of doesn't matter with this question which approach you take, you'll get the same answer. So we know that y is going to equal 44 times f, and the reason being is that they are opposite in, let's start a new line here just so I've got room. They're opposite in a parallelogram, which is absolutely fine to state as a reason. That is a known mathematical thing. The opposite angles in a parallelogram are equal. So that's going to be 44 times 3, which is going to equal 132 degrees. So y is 132 degrees. Here we've got angles on parallel lines, and if I connect the angles up, you can see that it kind of makes a bit of a Z pattern there, and we know that Z angles that are always equal, so x will be just 163 degrees. Now the key is figuring out y. The reason why I remember is because they're alternate. Okay? I just put the letter Z in alternate to remind me that's what it is. The actual reason is not with a Z in, it's alternate. But I always remember alternate, just bung the Z in there and try and remember that anytime you have these Z angles, then they are alternate. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here, and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom actually, that might be easier, and draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. To work out the area of a circle, we first of all need to work out what the radius is. Now the radius is half the distance of the diameter. So to work out what the radius is, we get the diameter and we halve it, which would be 15 centimeters. So the formula for the area is pi times r squared, or pi r squared. If we know the radius is 15, it will be 15 squared. 15 squared is 225. And the way we write this is we put the number first and then we just put pi after it when it asks us to leave it in terms of pi. So it'd be 225 pi. Now the reason why we would do this is if we want to keep all the precision, we can do it in terms of pi so we don't have to round it. So in this question we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. To divide mixed numbers, we need to convert them to improper fractions first. And to do that, we just do the big number times by the bottom and add it to the top. So 2 times 5, which is 10, and add it to the top, which will be 13 over 5. And the bottom, the denominator, stays the same. Divided by, and we're going to do 1 times 2, which is 2, add to the top, and we get 3. So it becomes 3 over 2. Then we're going to keep the first fraction, flip the second fraction, and change the sign. So it becomes 13 over 5 times, and then we're going to flip that, so it's going to be 2 over 3, times the tops would be 26, times the bottom, which would be 15. Now 26 over 15, there are 1/15s that go into 26, so that'd be a big 1, and that leaves a remainder of 11, so it'd be 11 over 15. So our answer would be 1 and 11 over 15. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100. Because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now, it says how many bread rolls can we make? Now, we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in twos. So this will be 28. So the x coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length. That will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5-meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. There are 2 rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin, so A and B cannot be in direct proportion. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10. So the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the 2 numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120, and we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid, and we're going to do x minus 15 at the top, x minus 15 at the bottom, then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x, same again here, and then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. There are a few different ways of finding out product of prime factors. I prefer using the bubble technique. So we just write the number out and we put a bubble around it, and we split that number into two numbers. So we find two numbers that multiply together to make that number. Now, I always pick the smallest that I can on the left-hand side. Now, the smallest I can think of is 2. And so 2 times 22 is 44. And now we think about 22, and that's 2 times 11. Now you might be thinking, why have I put the 2's in red? The reason why I've put them in red is they are prime numbers. We can't do another thing for the 2. Well, we can, it would be 2 and 1, but we'd be there all day doing 2's and 1's off the 2's. So we leave it as they are, and 11 actually is a prime number itself. So if I'm going to keep up with the theme, I can have that in red as well. Now, notice it says product of prime factors. So the prime factors are 2, 2 and 11, but the word product means times. So it's 2 times 2 times 11. Notice they're in ascending order, so it's 2 times 2 times 11. Now, if we were asked to do it in index form, we would write it as 2 squared times 11. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers, just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares. And we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them. So I cross them both out and put 2 in the middle. We can see they both have a 3 in them. So cross those 3's out and put a 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing. It's timesing the x by minus 6. So I'm going to divide both sides by minus 6. So that gets rid of the minus 6 on the left-hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be minus 4, 1. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62 take away 40, which would be 9 to the power of 22. So our answer is 9 to the power of 22. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour, because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one, and the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A, and we're going to draw an arc from point B. And you can see that the 2 arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. To go from meters to centimeters, we obviously times by 100. But to go from meters squared to centimeters squared, we times by 100 per dimension. Now, whenever we talk about things in meters squared, we're talking about areas which have 2 dimensions. So we times it by 100 squared. So when we've got a 2 meters squared here, we times by 100 squared to get it into centimeters squared. So that's going to be 20,000. The key to estimating is that normally you will be rounding numbers to one significant figure and then working out the answer. So I'm just going to rewrite this fraction here. But instead of 93, we're going to round that to one significant figure. So that'll be 90. We're going to round the 265 to one significant figure. Now, some people will write 270, but one significant figure means the line goes after the 2, and so that would round to 300. Then 31 will round to 30, and 97 will round to 100. Now the next step is to see things that we can cancel here. So we can divide top and bottom by 10 to make that a 9 and make that a 3. We can divide top and bottom by 100, make that a 3, make that 1. And we can divide top and bottom by 3, so that will make that 1, and that will make that 1. And so at the top we've got 9 times 1, which is 9. And at the bottom we've got 1 times 1. So 9 divided by 1 is just 9. So our answer will be 9. So you can see here that the triangle has changed size. So the transformation we're looking at is an enlargement. And we need to find out how much it's changed by, so what the scale factor is. And so we've got 2 at the bottom here of triangle A, and we've got 4 at the bottom here of triangle B. And so we are going to times the 2 by 2 to get to 4, so the scale factor is going to be 2. And last thing we need is the center of enlargement. And to do this, we're just going to connect all of the vertices, all the corners of the triangle with straight lines. Try and get it as precise as possible. And we've got the bottom left corners as well. And these are just going to be straight lines, aren't they? And we've got the bottom right ones as well, which will just be a straight line going the other way, if I get it perfect. There we go. And so where's the point they all cross? Well, they all cross at this coordinate here, and that is going to be our centre of enlargement. So the centre of enlargement is going to be at 3 minus 4. We're going to start off by just writing the decimal in the standard form, which is 4.3. And we're going to look at the power. Now, if the power is positive, it means the standard form number is a really big number. If it's negative, it means it's a very small number. And here it's negative, so we know it's a small number. Now we're going to do the amount of jumps that it shows in the power. So it says a 5 there, so we're going to do 5 jumps. And because it's a small number, we're going to go to the left to make it a small number. So we're going to go 1, 2, 3, 4, 5 jumps. The new decimal point is going to be here. All the jumps that we made, we're going to fill in with zeros. And because it's decimal, we're going to start it off with a 0. So our new number is, or our ordinary number is 0.00043. Now it's important to realise that we shouldn't really think about it as jumping the decimal point. We're actually shifting the number. But it's all relative, and it's a lot quicker just to move that decimal point. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4s into 2 don't go, so carry the 2 across. 4s into 28 go 7, and 4s into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power of 4, w to the power of 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. So to find the probability of A and B, which is what that sign means, we're going to work out the amount of people, or the amount in A and B, and we're going to put that over the total amount. So A and B means it's the overlap, so that's going to be 7, and the total amount is all of the numbers added together, which will be 23. So our answer is that the probability of picking A and B is 7 over 23. When you have a number next to a letter, it's the same as putting a times there, so we're just going to write this out, but by putting times symbols in. Put the numbers together and the x's together. So here we've got 3 times 7, which is 21, and x to the power of 5 times x to the power of 4. Whenever you multiply bases with powers, you just add the powers as long as the bases are the same. So they're both x to the power of something, so we're just going to add the powers together. 5 plus 4 is 9. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now, next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So here we're given a right angle triangle, and the question involves 2 lengths and angles, so we know we could be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here, we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.